little while ago, this image was posted to Reddit by a user called Simping is for Chad. Ignoring the username, I think this image looks awesome. And when I first saw it, I recreated it, and while I did get it working, it was really slow, even at super small resolutions. As you probably know, I've been messing around with shaders a lot recently, and I figured it was time for me to revisit this and get it running in real time. Just a quick disclaimer, this is just how I managed to do it. There's probably a million much better ways of doing this, but I think it's pretty cool, so I thought I'd share it with you. As always, the code for this demo is freely available in the description, so you can follow along and run this project for yourself in the browser. You'll also find a link to the original Reddit post down there as well, so check that out. The terrain I use for this comes from a height map, which is basically exactly what it sounds like. We can look up a coordinate in the height map and it'll tell us how tall the terrain is at that point. In the past, I've extruded this height map to actual 3D geometry, but often, like in this case, height maps are used in 2D terrain to figure out which type of tile should be placed where. In such a case, there is no 3D geometry to create lighting with, just a flat image of all the tiles, but you can still generate shadows as you can see here. To get started, we obviously need some height map terrain. The terrain really isn't the focus of this video, so I've kept it really basic and I won't go into too much depth on it. In fact, I've covered this style of terrain generation in a couple of old videos, which you can check out here. But for a quick refresher, here's what I'm doing. I'm using some Perlin noise to generate a random value between 0 and 1 for each tile. This value is the height of the terrain, and I can use it to determine the color or the type of each tile. To make sure we always get islands, I'm squashing the noise values the further they get away from the center, which pushes some of the terrain beneath the water level, creating islands. And that's basically all there is to it. I'm saving the height values in an image with the minimum height being black and the maximum height being white, and I'm saving the colors of the terrain in a separate image so that I can pass them both to the GPU when it comes time to figure out the shadows, which is what we're going to do next. To make the shadows, we simply need to darken any region of the image that isn't touched by light. The tricky bit is figuring out if a region is touched by light or not, and we're going to do that inside a shader. If you haven't used shaders before, check out my introduction to shaders video. It covers all the basics and teaches you everything you need to know to follow along with this video. I promise they're not as hard as you think. Our shader needs a few bits of information, and we'll pass it our two pieces of terrain data, the color map and the height map, as well as a 3D vector that'll represent the sun's location. To figure out if the fragment we're drawing is in a shadow or not, we need to know if there's a direct line between the fragment and the sun that doesn't run into any other terrain. The way I do this is create a 3D point from our current pixel's location for the X and Y, and I look up the height for that position to get the Z. I then find the vector that goes from this point to the sun's location, and if we take small steps along this vector, we'll eventually reach the sun. What we can do is check each step along the way to see if we're inside the terrain or not. This is done by simply sampling the height map at our current X and Y position, and if the height is greater than our current point's height, stored in the Z, we're inside the terrain, and we know that the pixel we're rendering is in shadow. And if that's the case, we can break out of the loop. Likewise, if our point Z is greater than 1, we know that we're above the highest terrain, since the height map is in the range of 0 to 1, which means we must be in full light, letting us break out of the loop as well. There's almost certainly a more elegant way of doing this, and if you know it, please let me know in the comments. If you're enjoying the video, feel free to chuck it a like and maybe subscribe while you're there. Cheers! So we now know if we're in a shadow or not. All that's left to do is use that information to make the image darker in the shadowed regions. And this is nice and easy. I just use a mix function to choose between the normal terrain color and a darkened version on it based on if we're in a shadow or not. And that's all there is to it. We're using a height map to cast shadows on 2D terrain in real time. Obviously, this method has its limitations. Since the height map data is in an image, we can only get as much fidelity as the pixels allow. Pixels are square, and you can see that the shadows look pretty blocky, especially when the sun's low in the sky casting long shadows. We can also see that some regions get a bit of a dithered texture. I actually think this looks pretty cool, but it's definitely an artifact of how the shadows are calculated. Like I said at the start, I'm sure there's heaps of other much better ways of achieving this same effect, but it's just what I came up with and wanted to share it with you. I've actually recently just set up a Discord server, so if you need help with some code, want to discuss a video in more detail, or just want to hang out with other creative coders and game devs, come and say hi. There's a link in the description. I think it might be fun to take this demo a bit further and add some more traditional lighting models by calculating the surface normals from the height map. I don't have time for that today, unfortunately, but let me know in the comments if that's something you'd like to see. On that note, thank you so much for watching, happy coding, and I hope to see you again soon.